So I'm going to record everyone. That way we can take a look at what is going on here with Tracy's problem. So let me see. Oh, no, not that. Nope, not that. Go over here. By the way, this is one of the neat things about Netlabs is you can go and look at everything that was typed in. All right, come on. So we got to manage usage. We look at labs. We pick our class, which should be,
it's gonna be fall 21.
Is that it? Fall. There it is, right there. 2021 fall. There it is. Okay, so it's that lab right there.
Yes.
All right, so let's
Look at mine too.
All right, let's do this. Let's first, all right, so lab 682. So let me go do this real quick. Let me pull this lab up. I know it's, all right, I'll come back to this. Give me 1 second because I need to pull the lab up. I need to pull the lab documents for this particular lab. 682, let's preview the lab and let's put it over here. I'll just download it. All right, to my download, save. All right, dismiss of that and put this over here. All right, so there's that, and then we'll pull this over here. Okay, now we're getting there. I need to have them both of them so I can see exactly what's supposed to be done here. Okay, so let's go here, this side, and here. Of course, today I'm working from home. I really need all my, screens. All right, so these two PCs are not able to get IP addresses, correct? That's what you're getting, the problem?
Correct. I can't get it. I keep getting an unidentified network.
All right, so let's see here. So let's go first and look to see R1. Let's look at your just final configs on R1. Let's look at our things. All right, so we got our IP addresses. Just make sure everything's good there. 248. Internal is 1/24, correct? All right, so we've got IP NAT pool public access 209.165.200.226 to 228, 248. IP NAT inside source list 1. All right. Public access, so that's right. That is correct. All right, let me see here. So it's all on VLAN 1, so there should not be an issue with, you don't have to do any trunking or anything like that. Okay. All right, I don't see anything wrong with that one. Let's do this. Let's got an idea. Let's let me just do this lab. Let me pull this lab up for us. And just real quickly, just do the internal portion because it shouldn't be that hard to do here. You on pod 9?
Yes, sir.
All right, I'll use pod 9 again just to make sure. Could be an issue with the PCs. I don't think so, but let's let that boot a little bit. We'll let this boot, and as soon as it's booted, we'll come back and we'll try again. But from what I saw right there, it looked to me like you had it correct. But let's just check to make sure again once we get it up and running. Let me make sure your pool is correct. Yep, and that pool is correct, definitely. 228, 226. Yep. By the way, what is this trying to do? What is this pull, one of the things I want to talk a little bit today with you was about the different types of NAT. And one of them obviously is static NAT, and that is a one private IP address to one public IP address. And where do we use that? Where do we use static NAT typically? Anybody, what would be the biggest use for static NAT?
Inside private networks.
Yep. So in other words, our servers, like you got to think about, if we have a web server that is sitting on a DMZ or sitting out on a DMZ, it's going to have a private address such as, let's say I had 10.0.0.200, right? And let's say that was a /24. Well, that is a private IP address. It cannot be routed on the internet. So on our firewall at the edge of our network, we would have a static one-to-one NAT that would NAT that private address to a public address, like a 209.211. I can't type today. 209.211.30.200 or whatever /24. And then that way you would be able to access that web server from the internet. So every server you access on the internet is being NATed to a public address from a private address. There's almost no servers that actually have a full public address on them. Typically, there's a NAT device in the middle. So this is how we use our static NAT, one private to one public address. Now, why don't we?
Can I ask you a question, sir?
Yeah, go ahead.
What you're saying is that I cannot, from web browser, I cannot access the server 10.0.0.200.
Correct.
Unless I use 209.211.30.200. Right?
Correct. So for instance, if I go in here right now, let's do CMD and let's do ping www.cisco.com. Okay. All right. So that's a web server, right? This www is a C name or canonical name, or it could be an A record, but it's probably a canonical name for a server or a group of servers at Cisco. The public address being used by that server is this 104.95.207.184. On the actual Cisco network, that server is probably a private address in the RFC 1918 range. And in fact, more than likely, what actually is happening is this. In the real world, there's probably 30 servers that are inside using private addresses that are all being NATed by this one address through a round robin fashion or through some other load balancing fashion to be able to respond to requests to this particular address. Now, the reason for that is, if you'll remember, these RFC 1918 addresses cannot be routed across the internet. All ISPs actually block the RFC 1918 addresses with access control lists on their incoming routers. So in fact, when you connect your network to an ISP, their ISP typically has unless they're using private addresses inside their network, typically has an access control list that will drop all RFC 1918 addresses. So that's why you have to go to this public address in order to get to this web server. And again, this somewhere, Cisco is NATing this address to a private address. Okay. Now, what is the problem with that? Why is that potentially a security issue? It's good from security standpoints in some ways because we don't really know what the internal IP address is of the device we're connecting to, but what is the problem with it? Remember and they don't really mention it well in the chapter, but the end-to-end traceability is lost. Okay, we can't really know exactly what machine we're going to. You know, we're going to this public address right here, but we really don't know what machine on the back end is NATed to that particular address for us on the outside. Now, obviously, the company that owns this web server knows, but you as the person connecting to it don't really know end-to-end traceability. So that is one issue with it. Okay. Another type of NAT that we have is NAT from a pool. Okay. And that's what's being shown right here in the lab. So we've created a pool of addresses, 226 to 228. So in other words, 226, 227, and 228. The negative of this pool and the use of a pool like this is that only 3 machines can access the internet through NAT with this setup, because there's only 3 IP addresses available for your host. Now, there's another type of NAT that they call just straight PAT, but I call it NAT from a pool with overload. And what overload does is it will take the final address in the pool and will perform PAT with it, which is port address translation, which is our final item. And with PAT, you take a single IP address, typically a single public IP, and NAT multiple private IPs to it. This is what we are all doing in our houses. So right now, the 20-something devices that I have on my network here in my house, they are all being padded to the single IP address that my ISP is giving me on my home router. Okay. Does that make sense?
Yes.
So let's do this. Let's go back over here and let's go in and let's see if we can enter the lab. And I'm just going to very quickly do base config here on R1. And the only thing I'm going to do on R1 is just put the IP addresses on it. Host R1. I am going to do this on con 0. I'm going to do logging console synchronous just so I don't have stuff hitting my line here. Okay, so let's go int G000 IP add 209.165.200.230. Is it as cold where all of you are at as it is here in North Carolina today?
No, it's mid-60s here in central Alabama.
Wow, it's 44 degrees here today, 45, which for us is pretty chilly this time of year.
Yeah, for 3 here in Memphis too.
Oops, that won't work. No shut. And I'm going to go do my IP route. Oh, not route, IP route quad 0. So do my default route. Going over to R2's 209.1.200. Correct. Yeah, that's right. All right, let's do a do right here real quickly. Let's go to R2. Go to R2. I'm gonna do for some sitting there clicking the wrong thing. Okay, so host R2, line con 0, login synchronous, exit int G000, and let's do IP add 209.165.200.225. And all I'm going to do is get basic connectivity between these two up and running. And then we will know that at least we can do that. So let's do a Control Z, right. So say ping 209.165.200.230. Yep. All right. So we got pingage between R2 and R1. So let's go to our PCs, put our IP addresses on them. So let's go here, change adapter options. Oops, I disabled it by mistake. Go to properties.
192.168.
1.2,
Yep.
and then 192.168.1.1.
1.1. Yep.
All right, so okay. And then I'm just going to test connectivity from here up to my router just to make sure I got that. So let's do a ping 192.168.1.1. All right, so we know we got pingage from there. So let's go ahead and do PCB too, although we really don't. We could do that without doing the PCB, but let's do it just for grins. All right, so 192.168.1.3 tab 192. Notice one thing that Windows will do is it will always put the default mask for the range of addresses that you put in as an IP address. So if you are going to using the default mask that is typical for that class of address, you don't have to just say, yes, that's fine. Let's do a CMD ping 192.168.1.1. All right, and I'm gonna ping 1.2 just to make sure I can ping my other one, which really doesn't matter. All right, so I have full pingage. So let's go to R1 now, and let's set up our NAT pool. So we're gonna set our pool up here. So the first thing we're gonna do is an access list. So access list. Now, what is this? This is called a Nat Acl. What does it do for us? What is the actual purpose of this access list? The purpose is to determine what can be natted. So this is saying anything that matches this access list, allow it to be natted. Okay. So now we're going to create our pool. You know what? I think I just found your problem. All right. Let's see if it works, and then we'll go back because I think I see where you missed. IPNAT pool public underscore
access 209.165.200.226.
All right, 226 space.
Yep, space 209.165.200.228 space net math.
All right. Isn't it 248?
255.255.248.
All right. Now let's go then IPNAT inside. Now what this does is it links the pool and the list. So it's on saying anything that matches list 1.
List pool 1 public underscore access.
And it has to be the same case sensitive. All right. Then we go int G001.
Yep.
IPNAT
pool inside. Yep.
And then we hit up arrow twice, 0 IPNAT outside. All right. So now let's go all the way to PCA and let's ping 209.165.200.225. I think that's what R2 is, correct? Yep. All right. So let's see if it's working. Well, yeah, it might work. Ping. I don't know what's going on here. Let's go back to here and we'll do Control Z, right. There it is. I don't know why it wasn't clicking. All right, let me try something. I'm gonna do what's called an extended ping. This is where you can ping and you can set the source IP address. By default, typically the source address is the closest IP address or the closest interface IP. So if you go in here and you say, yes, I want extended commands, I can actually source this from 192.168.168.1.1. And just hit enter and let's see if it works. Okay, so that worked. Let me go back here. I think I may have typed that wrong. Nope. All right. Let me see if I ask you to do the okay. Oops. Show IP Nat. Yeah. So it's okay. Another translation's 1. All right. So let's see here. Configure IP address to R2 from R1, say the router configs. So they should be able to ping, PCA should be able to ping all the way out. Let's do this. Let's ping to, let's do a control C here. Let's ping to, okay, so we're good there. So let's ping to 209.165.200.230. All right, so that is, it will, I can't get to 230.
To the router.
I can get on the other side of R1, right? 225. Oops, come on now. Okay, that worked. So it did work. So I'm able to ping all the way out. So I should now on R1, if I do a show IP NAT trans, there it is. So you've got it. There it is translating. So let me go back to PCB. Let me do the exact same thing here. Let's ping 209.165.200.225, which is R2. There it goes. So now that's working. So we go in here and do a show IP NAT trans. We should see a new translation now. Say 1.2. See how it's being translated to, let me make this bigger. It's being translated to 226. Okay. And let's do it, enter here. And then the other one's 227. So in our pool, you'll notice that the first address is used for 1.2. The second address is used for 1.3. What's going to happen when we use up all of our addresses? Nobody else will be able to go out until these timed out. But I think I know exactly what you're missing. I think what I saw missing was linking the two together. I think you did. Here's your final configs. No, you didn't. You did link them together. So IP NAT pool public access 209.165.226. Okay. That is correct. Tracy, I don't see anything. I don't see anything wrong with this config. And you were saying even when you put the IP addresses on the interfaces on the PCs, it would not translate.
It wouldn't translate at that particular time. Yeah.
Okay. Well, I know
Hey.
it is translating. Now I don't know whether there's a. Now I see here. Let me do a show IP NAT trans again. See, these will eventually time out. Let me show you something neat too. If we want to change from let's do a show run here. Let's just make sure our configs are the same, which they are. I know they are. So IPNet outside, IPNet inside, IPNet public access. So that's exactly what you've got, public access. No, I don't see anything different there. But how can I change this pool to be NAT with overload? Anybody know how to do it? I'll show you how easy it is. Watch this. If you want to change it, all right, so I'm gonna put that in there. We're gonna get rid of it first. Oh, it's in use. Okay, so I got to do no IPNet inside source list one pool public, because it's in use. You can't delete the pool. So done it. All right, so let's do this. Let's do clear IPNet trains star. All right, now we should be able to do it. Yeah. Okay, so let's do get rid of that. And now I'm gonna do this. If I do an IPNet pool public underscore access 209.165.200.226 209.165.200.228 net mask 255.255. All right, then I can do IPNet inside source list one pool public access overload. Now watch what happens. So let's watch the difference in how NAT works now. I put the wrong command in there, so it's going to take it a second to time out. But let's go back to PCA and let's ping. Okay, so we got a ping there. Let's go to PCB and make sure we can ping, and we do ping. We'll go back to R1, and it's going to take it a second to time out of this mistype I put in there. I forgot to put no IP domain lookup, so it's trying to do a domain lookup. There we go. I did it again. I'm trying to do Shift Control 6X, which will work on real equipment, and this is real gear, but it's not sending that to it. It's trying anything. Come on. We just gotta be patient. What you're going to see now is instead of being just NAT to the IP addresses, so instead of mapping the first one to, instead of mapping the first one to 226 and then the next one to 227, it's actually going to map both of them to 226, and it's going to use port numbers, because that's what overload does. Overload allows you to use port numbers instead of your pool numbers. Okay. So again, you see the types of NAT. They talk about static NAT. They talk about dynamic NAT. And with dynamic NAT, they're talking about dynamic NAT to a pool. And then I call it dynamic NAT with overload. And then there is PAT. And what we'll see here, if this ain't there, finally finished. Well, maybe it didn't. Come on. And this, folks, is why you always put in no IP domain dash lookup. So you don't have to sit and wait like this. Because what it's trying to do right now is go out to a DNS server and figure out what computer is named XXXXX. So there we go. All right, so config T, no IP domain. Let's definitely put that in there. All right. Now let's do a show IP NAT trans, and you'll now see, oh, there's no translations because they timed out. So let's go over here and do our pings again. And let's ping from here. And we should be able to see translations. You'll notice how instead of translating the first one to 226 and the next one to 227, you'll see how it used port numbers and translated them using port numbers so that this particular IP address can use as many of the internal addresses as you want. And in fact, what it'll do is, I think they state that you can put up to 4 million internal IP addresses on a single public IP address.
That's example of many to one public address.
Correct. That is correct. And then what I want to do is I'm going to show you the final method. So we just looked at dynamic NAT to a pool. We looked at dynamic NAT with overload because that's what this is. Okay. But now I'm going to do one more thing. I'm going to go clear IP NAT trans. By the way, if you ever need to clear your translations for some reason, clear IP NAT trans star will clear all your translations. Then I'm going to go config T and I'm going to no IP NAT inside source list one pool public underscore access overload. Overload. So I'm getting rid of that. And then I'm actually going to do, so we can actually get rid of this entire thing. Control A, do no. So now I've gotten rid of the entire pool. But what I'm going to do now is I'm going to do IP NAT inside source. And then you'll notice you can actually make it list one. And then I'm going to go to interface G000 overload. Now, what this is going to do is it's now going to take the IP address on the gig 000 interface, the outside interface, and everything that goes out from the inside is going to appear to be from that IP address. So you can see I can still ping, I can still get out to the 209 numbers, but now when I do a show IP NAT trans, look at what it's being translated to. It's being translated to the IP address that is configured on, see, 230. It's being configured on the outside. So 230 is not only being used by the gig 000 on R1, it's being used for all NAT on the inside. You'll even see it knows what protocol was used. It's an ICMP connection. All right. Watch this. Let's do, let's go to R2 and let's just real quickly. Okay, let's do config T, domain name, IP domain name, cisco.com. Let's do user name, sorry, I can't spell, name admin, password, Cisco. All right, that's fine. We're going to do crypto key generate. What I'm doing is turn on RSA, and we'll do 1024. Do line V2I 04. We will do login local. Oops, login local, and then we will do transport input SSH. Okay. So let's go to PCA, and let's take and let's SSH over to so it'd be 209.165.200. What is R2's IP address? So 225. All right, so yes, admin. Let's go. So now we're connected to R2, and I'm gonna go back over here, and I'm going to ping it again. And I'm gonna go to PCB, and I'm gonna ping from here. And you'll notice when we go to R1 and do a show IP NAT trans, look what's happening. We've got an ICMP connection from the PCA. This is PCA, but we've also got a TCP connection. And you look, it's from this source port to this destination port. And TCP port 22 is SSH. So this is showing you how using port address translation, the same IP address that is used on the physical interface of R1's outside interface is being used by all inside hosts to have outside connectivity to the world. Okay, so they're using that right there. That, folks, is the only reason why every single one of us is not running IPv6 on everything that we own. Because without this, we would all have to be running IPv6 because we would have been out of IPv4 addresses so long ago, and there would have been no way for us to continue to use IPv4. This ability to do many to one public IP address through NAT is the reason we can continue to use IPv4. Questions about that? Now, Tracy, why yours didn't work, I don't know. That is a very, did anybody else have a problem with theirs not working?
Well, I tried it, but I think I get more light now than the way that you show it, of course.
Okay.
I have to go and try it again and see what.
Okay.
The last one that you just show us now, is that one private to one permanent public address? The last one that you just showed us.
No, the last one I just showed you is called port address translation. And so it takes a single public IP address and NATs multiple private IPs to it. So this is port address translation. What I just showed you here was this right here, where you basically are taking the outside IP address on a device and everything inside is being NATed to that outside public address. And so that was just like this. This is what we just did right here. So we took these inside local addresses and we converted, well, we NATed them to this outside address, outside IP address. Now, let's see if we can show Nat and Pat. Basically, Pat maps one inside to all, or one outside to all the insides. And that's exactly what we just did. Because like I said, on R1, you'll notice there's only one IP address that is a public address. That's 230.
Okay.
So any connectivity from inside here going out is sharing that address. Let me see if I make this a little bit. Let me actually try to undock this and see if I can make it a little bigger so you can see it better. Try to do a translation now. Not a little bit better, but let me try again. Hold on. No, I'm still not doing it. But see, this is the inside address here, this 1.2, 1953. And then this is the outside address right here, which is 230. So that's what we're NATing to. It's that 230. The beauty is, again, both PCA and PCB can use that exact same address to get their external connectivity to the real world. So see here, here's 3 and 2, and they're both using the same outside address, the 230.
When we are working on this one, how can we troubleshooting the NAT and then the PAT address?
Okay, troubleshooting, that is a very good question. One of the things I do for troubleshooting, what I typically do first is exactly what I just showed you a little bit ago. So let's say that I'm going to do a clear IP NAT trans star. Okay. So, and I do a show IP NAT trans, and I've tried everything and it's just not translating. There's no translations. I will normally do an extended ping, and I will ping an address out there. So I know that 209.165.200.225. I usually bump my count up a little bit, but and then I go down here to extended commands, and I will use the inside IP address of the router itself. So 1.1, and then, all right, this should all work. We should get 10, and then I should see translations. Nope, didn't translate. That's unusual because typically I will see translations here. All right. If I don't see translations, one of the first things I'm going to do is I'm going to check my access list. Why?
That's why we give you the.
This tells me what can be translated. Correct. So this says anything that comes from 1.0 can be translated. I can't tell you the number of times somebody accidentally put 10 in here instead of 1. And it will not translate if the incoming IP addresses don't match this. So when I do a show IP NAT, and let's see if I can do anything. Pool, I can look at the pool. Pool, you got to give it the name. Public _ access. Okay, you'll notice there's no pool because I don't have the pool. But we can do statistics, show IP statistics. You can see here there was 126 hits, 13 misses. A lot of times if I see no hits and bunches of misses, then I know that more than likely I've got an access control list problem. All right. The other thing I will tell you, this is one of the few times that honestly a show run works, because to my knowledge, there's no way to see if inside and outside has been set without doing the show run. So when you really think about NAT, it's a pretty simple process, especially if you're doing PAT. With PAT, the first thing you're going to do is this: you're going to create your Nat Acl. All right. Number 2, you're going to associate your Nat Acl to the interface and overload. And then you need to set your inside and outside NAT interfaces. I see in all the competitions that I run, I see a lot of people do these first 2 and then they forget to set their inside and outside. And another place I see a lot of problems is when, let's imagine that instead of everything being here on R1, what if you had sub interfaces in here? What if you had multiple VLANs on R1? If you had sub interfaces, you would actually have to make sure you set all the sub interfaces as inside or, well, be inside. You have to set them all as inside. Otherwise, you will not be able to get your NAT translations to take place. So really, NAT creation is pretty easy. Typically, especially with PAT, create your ACL, associate the ACL with the interface and overload it, set your inside, outside NAT interfaces. If you're doing dynamic NAT with a pool, from a pool, well, the first thing you're gonna do is create your ACL, your NAT ACL. Then you're gonna create your pool. Then you're going to, you actually need to spell create correctly. Then you're going to associate your ACL and your pool. And then finally, set your inside, outside NAT interfaces. So it's really not that complicated. And when you're talking about troubleshooting, typically where things go wrong is in the ACL, or sometimes folks do create the wrong pool or don't use the right subnet mask in the pool. But most of the time, I'd say 60 to 70% of your errors are wrong ACL, or you just forgot to do the inside-outside interfaces. Which is why it's, troubleshooting is really not that difficult with Nat. Okay, questions? So again,
That is more.
go ahead. Yeah. Here's static NAT again, simple one-to-one, one inside private to one outside public. Okay, this is very simple to configure. So your IPNAT inside source static, and here's how I remember it. I do IPNAT inside source static, inside outside. So that way, you put your inside IP address first, your outside IP address next. So IO, IPNAT inside source static, IO, inside outside. And then you still have to set the inside and outside address on your, or not address, but status on your interfaces. And then you can very easily see that with a show IP NAT translation. You'll see a static NAT, an inside to an outside. Dynamic NAT, super simple. Again, we go in here, when we go to configure, step 1, configure ACL. Okay, what they've created their pool as their first step. 6.5 doesn't always create my ACL first, but their pool, then they create the ACL. They associate the pool and the ACL, and then set your inside-outside interfaces. And then if you want it to be overload, you simply just put overload at the end of the pool, at the end of the statement that puts the two together. So this, if you wanted this to overload to this pool, you would just put overload after this command, binding the ACL to the pool. Okay, and then finally, PAT is what I just showed you when you're going to use one public IP address that's already on an interface. So we just do IPNAT inside source list 1, the interface you want to overload to, and then overload. Make sure your ACL is there and inside outside. This is what all of our consumer grade routers are doing in our homes already for us. They do this automatically when you turn on NAT or PAT on your device. Questions? And here they call it using PAT with an address pool. That's what they call this. I call it dynamic NAT with overload. So I have a different name for it than what the curriculum calls it. They call this PAT with a pool, but I call it dynamic NAT with overload. The actual way this works is it does a one-to-one translation on the, well, the way it used to work. It looks like it's working a little different in the new iOS, but it used to be do a one-to-one translation for all of the addresses in the pool up to the final address, and then it would overload on that final address. But what I just saw from the example I gave you on Netlabs, it looks like iOS 15 may be doing a little different behavior than earlier iOSs. Okay. Any questions? Again, show IPNAT translations. That's one of your best commands. Show IPNAT statistics. Also, if you see a lot of misses, that means that the ACL is not hitting the traffic that's trying to go through. So your ACL is probably wrong. So just be aware of that. That's a good way to see that. And that will show you your access list here. You can actually see if you go on down further under show IPNAT statistics. Let's go in here and do this. Let's do a control C here. Show IPNAT statistics. Okay. It's showing you here the actual access list, and it's showing you the statistics as far as what's drops and misses. Let's do this. Let's do actually another ping and watch that go up so you can see it. You can actually see if it was 126. Nope, don't the power. 126. We should see it. I don't know why that didn't go up. That should have gone up. try this. There it went. Okay, just took it a little bit. So you can see how the hits went up. Okay, showing that it is actually hitting that access control list and actually using that. All right. Any questions about Nat? Next week, what do y'all want me to cover? What do you want me to kind of go over next week? Well,
can you do the, because we're going to do the VPN and ENSA is going to cover VPN and then.
yeah.
But I think that VPN is going to be a good one because I think that most of the school now they want the student to use the VPN.
Yep.
So
I'll go over that. I'll go over that and maybe the QoS concepts next week, just to give you an idea on those. So, okay. All right. Any other questions about anything that we went over today?
No.
I do want to show you one thing before we call it a day. Let me share my screen real quick again. Inside of Nat Acl, I know I've shown you this, but if you haven't had a chance to do this yet, I'd strongly recommend under your instructor professional development here. All right. Down at the very bottom is the academy orientation. And I know most of you enrolled in this when we were doing CSNA 1, but if for some reason you didn't have time back then to do it, this is a self-paced orientation course. Go here again, it's under resources, instructor professional development. Scroll all the way to the bottom and enroll yourself in this academy orientation course and do that because it will help you a great deal with simple things like creating classes, creating student accounts, those types of things. You also have here IPD week, which is instructor professional development week. And inside of here, you can enroll for our next set of sessions, which will be coming up. In fact, you can, next one is November 29th through December 3rd. And once you get enrolled in IPD week, you actually have access to all of the old sessions and things that are available so that you can go and look at different items that have been presented through instructor professional development week. And you can even get an instructor professional development certificate for the number of hours that you watch certain things during that week. So the next one is November 29th through December 3rd. They do a lot of good updates here. So if you have not signed up for instructor professional development, do that. If you have not done the orientation, I strongly recommend enrolling in that academy orientation.
Kelly, quick question, Tracy.
Yeah, go ahead.
On my interface, well, can you see, am I still set up as a student? Because I don't see that resource on
You
my.
probably are. More than likely you are. You need to get the instructor role at your academy. If your academy is not set up yet and you want the instructor role, and you don't know when your academy is going to get set up, send me an email and I'll give you an instructor role underneath my academy. Okay. And then that way you'll be able to see this.
Okay.
But yeah, you do have to have the instructor role in order to get this.
Okay.
And if you are a manager of an academy, the way you give someone the instructor role is by going under I'm managing, finding your academy, going to the user. I'm not going to show any users, folks, because would obviously not be a good thing to do. But I would just go under my users here, and then I would give you the instructor role at my academy. So I will do that if you don't have your academy up and running and you want that. Just send me an email and I'll take care of that.
Awesome.
All right. Any other questions? Dr. Harrison, do you have a question?
I was going to say, you just answered one of my questions because I'm trying to pull our university together to start this in January.
Okay.
And I want to know what are some steps or things that we should do. So you just listed a couple.
Yeah, that's a gotcha right there. If you don't give everyone, even if they've been in our classes, Dr. Harrison, if they are not have not been given the instructor role at your school, they're not able to create any class that they've either accredited for, or, you know, all the classes you don't need accreditation for, like Linux Essentials and Introduction to Cybersecurity and all of those. You can't even create those unless you have the instructor role at your school. So just make sure you give them that role.
Do you have a checklist or a cheat sheet for all the things? Because you keep giving us little tidbits. And I was like, I jotted that one down.
Yeah, that one I don't. I do have a series of videos on my ASC ITC on my. If you go to my YouTube page again and look,
Okay.
there's a playlist called ASC ITC tutorials, and inside of that playlist are most of these things. Well, I know that's there. Giving the instructor role, sharing users between academies, those types of things. Those are all pretty much in there. So that is available there. But yeah, any questions? And I tell you, as we're getting you started, it'd be a good idea for us to just have a meeting with Hampton and get everybody together and just get all the stakeholders and figure out what you want to do and how you want to do it. And I can give you all the tips and tricks.
That would be very helpful.
Okay, excellent. All right, everybody, that's all I have for today. So